Good afternoon, viewers. Today's topic is pointers in C programming. So, this is a very important topic, and then please concentrate on this particular topic. Why? Because this topic will be helpful for you in your due course of time, like while you are studying the data structures, that is MCS 21. And then in the third semester, there is another course on design and analysis of algorithms. So this will lay you a good foundation, and then if you are through with the arrays, structures and pointers, then you will be very much comfortable doing the programming or else writing the programs using the other data structures. So in the earlier sessions, we have seen the preliminary aspects, and then we had seen the user defined data types that are arrays, and then in the previous session we have seen the structures concept. And when we normally declare a variable and initialize its value, a normal variable is a location in memory that can hold a value. So whenever from the programmer's perspective, whenever we refer to the variable, that is the name, the label that we had given, suppose int I is equal to 10. So I is a variable and is being initialized to 10, and it is of data type integer. So in some compilers it will occupy 2 bytes, and in some compilers it occupies 4 bytes. So for example, when you declare a variable I as an integer, in some compilers 4 bytes of memory is set aside. Normally we talk that it is of 2 bytes. So in your program, you refer to that location in memory with the name of the variable, that is I. So till now we are not referring to the actual memory address. So whenever we talk about or whenever there is a reference to the variable, obviously we are referring to that location and its value stored in that location. So at the machine level, when we see, this is the programmer's perspective. So at the machine level, that location has a memory address at which the number of bytes, the data type that it occupies. So let us define a pointer. A pointer is a variable that stores the address of another variable, that is integer I is equal to 10. I is the variable name given and the value of it is initialized to 10. As you can see at the machine level, I will be storing in certain location. So for each and every memory address, every memory location will have its own address. So for example, an integer variable holds an integer value. And then suppose if the address of that integer value, that is the address of I, for example, is stored somewhere, that somewhere is not a normal variable, however, we declare in the form of a pointer. So as you can see, pointers store addresses of the variables, whatever the data type it may be. Like suppose if I declare a pointer variable as integer, so it stores the address of a integer variable. So there is a big difference here, you can notice. Variable, it is separate, and if you capture the address where in which it is stored in the memory location and store that address, then it requires a pointer variable. So the next question comes here is, why to use pointers, or else why to access directly the memory locations instead of the name given to the variable. Let us see the characteristic features, or else let us concentrate on the uses of the pointer variable also. In order to understand it better, let us see a simple example which is very much relevant. Suppose if you are living in some society, and then that society will have a name or else an apartment, wherein which you will be located in flat number 104. So it is the specific address, the area name, or else let us come straight away from the state, then city, then the area, then the society name, then your flat. So this is a kind of complete addressing scheme that we follow whenever we want to identify the address of a person. So the same way, if you want to access the variables with their addresses, so all the variables, whatever the data type it may be, those will be occupying certain memory locations. So those, if at all we want to access the memory locations, then the same way the value, same way whatever the addressing scheme that we are normally following, like in order to capture the addresses, some things are required. That something is nothing but the pointer. It is not a normal variable. However, the pointer variable stores the address, that is the underlying term, address of the variable. So whenever it comes to your mind a pointer, then it should strike that it is nothing but it is carrying an address. Suppose it is a simple variable, integer variable, the integer variable's address is been stored, or else the first location. Suppose it is occupying 2 bytes, the first location will be stored, and it says that it is an integer, it occupies 2 bytes. Or else if it is a float, in some compilers it will take 4 bytes. So the start address will be noted, and it will, as you are declaring the pointer variable as the float, it occupies 4 bytes. So right now it is clear to you that what is the difference between a variable and then what is a pointer variable. A variable is a normal variable wherein which we are using it in the programs in order to carry out in order to store the values during the course of time of the program. But however, when we talk about the pointer variable, it stores the addresses of the variables. So a pointer in C is used to allocate memory dynamically at runtime. The pointer variable might be belonging to any of the data type, as I told you, like it may be an integer pointer variable to a float, character, double, short integer, long integer, whatever the case it may be. So let us see the characteristic features of the pointer variables. So how these pointer variables are helpful during our programming? The program execution time will be reduced because we are not accessing the values or else the variables by its name. We are accessing it by its reference, or else directly the memory locations are being targeted. So obviously the execution time will be faster, will save the memory space. The memory access will be very efficient because we are randomly talking about the address. Directly it will go and search the address, fetch the value and performs the calculations or manipulation. Dynamic memory can be allocated, like instead of the static memory, suppose if you are having an array, character array of size 25 you had declared. However, in most of the times it is having only 2 characters. So it is wasting the memory. Likewise in arrays, structures, most of the memory space will be wasted. Suppose if you have this pointers concept in your mind and access those structures, functions, arrays with the help of the pointers, which we will be looking into the due course at the end, towards the end of the session, how to use these pointers with arrays, structures and other things. So dynamically you can allocate the memory, wherein which you can cut short the wastage of memory, because in the system the primary expensive part, expensive thing while the program execution is, one of the thing is the memory part. So whenever you talk about the static kind of allocations in certain programming languages, they themselves have the fixed boundaries in place, and even though it carries less values, even whatever that is been allocated, the space allocated or assigned for those value, those space will be taken as the total space. And then the next is the use of pointers. So characteristics we had seen. So what exactly are the uses when you program it through the pointers? So they are used to create dynamic data structures. C uses pointers to handle variable parameters passed to the functions. In the earlier section, when we talk about the functions, the arguments whenever you pass, directly you are passing it by call by value. So if you refer those things with the help of pointers, that is accessing the address kind of thing, then obviously the execution will be faster, and then exactly the whatever you are that the address is intended to fetch, it easily fetches the value and performs the functions execution. So pointers in C provide an alternate means of accessing information stored in arrays, which is especially valuable when you work with the strings. Here you can see a variable transparently stores a value with no notion of memory addresses. That is in our mind from the programmer's point of view, but at the machine level, the pointer variable points to the address. How to declare a pointer? You can see here integer star we are using. It is a pointer variable pointing to an integer variable. And then P2 is a pointer variable which is pointing to a double data type. Likewise, a character and then float. This is how we declare the pointers. So where to declare the pointer, where to declare these pointer variables? Along with the declarations, that is after the main we will be having the declarations section in a C program. There you have to declare the variables, you have to declare the pointers, even you can declare the structures, functions, whatever that are meant for use in the program during the course. So whatever we want to use in C programming, those needs to be declared in the declaration section. So as usual, these particular pointer variables, in order to carry the addresses, needs to be declared at the declaration section. So what are the symbols that are used for address in order to capture the address, and indirection operators, that is to access the values that are stored in the addresses. So the operator that is available in C for this purpose is ampersand. So as you see in the example program, we are fetching the address using the ampersand. Ampersand NUM was the thing that we are using in the earlier program. So the address of operator is nothing but we are fetching it using ampersand. If you remember, when you want to fetch the value from the user in your program, what you will write? Printf enter value 1. So by looking into that, the user enters a value. So how you are capturing that particular value into your program? Scanf you are using, and once again there also you will be adding an ampersand in order to capture the, means that you are storing with some address value. So along with the scanf function, you will be using the address. The same address of operator is this particular address of operator that we are talking about. There is no difference between them. The operator ampersand and the immediately preceding variable returns the address of the variable associated with it. So another unary operator is there, that is the star. As you can see, whenever we are declaring a pointer variable, we are associating a indirection operator, that is the unary operator, that is the star symbol. Or else, suppose if you want to access the value or else the address of that particular thing, then also you can use the star operator as value at address or indirection operator. It returns a value stored at that particular address. So let us see a simple program. Here example 1, integer I is equal to 5. This is a normal variable and I is initialized to 5. Then int star j. So from this you can understand that j is not a normal variable, it is a pointer variable and pointing to a integer data type. So j, whenever you want to have it in order to store the address part of j, so j is equal to, we are initializing ampersand I. Rajesh, ampersand I. So you can see here the j is storing the address of I. So here j is pointing to a integer variable. So suppose if you take float star j and if you want to store j is equal to ampersand I, it won't allow. Why? Because there is a difference. I is an integer and you want to store a float and star j wants to access a float thing. So in example 2 you can see float a is equal to 10.394, then p is a pointer variable pointing to a float. So here you can capture the address of the float a. So p is equal to ampersand I. So p is nothing but p is storing the address of a. So here you can see an example given in order to showcase the address of and indirection operators. Variable declaration and initialization is done. Then there is a pointer declaration, p is a pointer pointing to a int. Then assigning address of number to a pointer means p is storing the address of NUM, and then here you can display the value that is stored in NUM as well as the address of NUM also. So whenever you are printing the address, then you have to use the format %p. Okay. So this is get value pointed by the pointers. So here PC is a pointer variable and C is a normal integer variable. C is initialized to 5, a value of C is equal to 5, and the address of the C is stored in PC. So printf %d star PC. So here you can see whatever the value that is stored in the address which is assigned to PC. So in order to fetch the value, in order to fetch the address, you have to use the format %p comma address of, or else you can simply write PC. But in order to fetch the value that is stored in that address, you have to use the star, that is indirection operator. You can see here it don't display the address. If you use star PC, it displays the value that is stored in the address, that is PC's address. So in this way, if you want to access the value using a pointer variable, this is the way you have to use. Let us make a clarity kind of thing, how to display the value, how to display the address of these particular values through normal way and through the pointer way. So here you can say v equal to 10 and then p is a pointer pointing towards int, and in that particular p I am capturing the address of v. Value of the variable directly you can display, that is 10, but value of variable with the help of the pointer, that is you have to use star p. Once again 10 will be displayed. Address of variable v, that is ampersand of v, that is directly you can say p or else address of v. Both the ways is correct. So one way is ampersand of v, the other way is directly as ampersand of v is being initialized to p, that is the pointer variable, so p also will do. So both the steps are similar, and then one we are directly doing and the other way we are doing it through the pointer variable. And the last printf statement is address of pointer p. So here you can see, even though we talk about the pointer variables, those also will have the address. As v is stored in certain memory location, and then p is a pointer which is capturing the address of v. So once again, the pointer variable also will have its own location. So that you have to see. There is no other place wherein which it will be stored separately. So it will also will have a separate location. Suppose if v is having 2000 as the address, so at 2000 memory locations address, 10 is stored and the name of that integer variable is v. Here p is a pointer variable wherein which we are capturing the address of v. That is, inside the p, the value of p is 2000. So this p also will be storing in certain memory location. It may be at 3010. So here the last printf statement is address of pointer variable p. So that is what the printf statement intended here to do. So just see here, v with value 10 is stored at certain address, and that particular address is been stored in a pointer variable p, but p itself will have its own address of 2 bytes, maybe 2 bytes because it is an integer. So that is how you have to interpret the program. Then null pointers. Pointer variables should always be initialized when they are declared. You should not just leave like that. It should be assigned. In the earlier case, v is there, v's value is been initialized to 10, and then the pointer variable p, integer pointer variable p is equal to assigned with address of that particular variable, that is v. So always the pointer variables should be initialized. Uninitialized pointer variables, pointers, start out with a random unknown values. Suppose if you run the program, this time it will present some value, and if you run once again, because it will take automatically a random kind of value or else a dynamic memory allocation kind of thing. So it will give you different kinds of values, and accidentally using a pointers containing a random address is one of the most common errors the programmers do. And always it gives you a different kind of values since they are not repeatable. One time it may be a one value, and the other time when you run the program it may take another value. So if you don't have any better value to use to initialize, better you use the NULL. So you can see the example given over down there. DPTR is a pointer variable of data type double. So for the first time it doesn't have any address to store. So better you do it, the initialization with a null is equal to NULL is the keyword you have to use over there, and then put the delimiter, that is the semicolon. So you have to remember, whenever you start with these kinds of pointers and other things, those should be initialized. Then comes the concept pointers and functions. So it is a simple program given over here. FUNC is a function, and the parameters, one parameter is a normal variable and the other parameter is a pointer variable. So here in the main program, x is equal to 100, that is the value initialized, and y is also an integer variable and it is assigned given a value 100. So both x and y are carrying 100, and then function is been declared over there. Printf x is equal to %d, then y equal to %. Before that we had called a function with parameters x and then one address, that is one pointer, one address, the ampersand of y. So whenever it is having two parameters, obviously there is a function, you can see it down. So here a is equal to x. You can see FUNC, there we are calling the function. Obviously the control will be going to function, FUNC function. Then a will capture the x value, that is a is equal to x. And then whenever it wants to capture the address value that is been passed from the function, that is calling function, here in order to capture the address, normal value is not sufficient. As we know, it should be a pointer. So BPTR is a pointer variable which captures the address of y. So here the value is given as a is equal to 42 and then star BPTR is equal to 42. So whenever you display the value at the top, obviously x is equal to, you will get the print statement as x equal to 100 and then y equal to 42. So in order to, you have to underline one particular point. Whenever the calling function or x is normal integer variable, but the other parameter is the address. So in order to capture the address, the down parameter should be a pointer variable. So that thing you have to notice. So this is a simple example in order to see the relationship of pointers and function, that is use of pointers in the function calling arguments. Then comes pointers and arrays. So pointers and arrays we use very much in the programming. So here I had written one simple program. You can see x of 4, that is an integer array and size is 4, and then a simple variable I is an integer variable. For I is equal to 0, I less than 4 plus I, and then here I wish to capture the addresses wherein which x of 0, x of 1, x of 2 and x of 3 are stored. I don't want to display the values of x of 0 to x of 3. However, I want to display the address wherein which x of 0 to x of 3 are being stored. So for that the format I want to use is %p, and then here you can see I am not capturing the value. However, I want to display the address of x of I, that is address of x of 0, address of x of 1, likewise x of till x of 3. So as all of them are integers, that is integer array, and occupies 2 bytes. You can watch here x of 0 is stored in the last 3 digits. I will read out 448 and then plus 2, because integer occupies 2 bytes in this compiler. Then 450 is the next position and x of 2 is stored in 452, 453. Then x of 3 is stored in 454, 455. So here you can see it is a continuous locations, array will be occupied in the continuous kind of thing. Then it is leaving alternate, like 48, 49 is assigned to x of 0, 450, 451 has been assigned to x of 1, likewise. So hope you had noticed the difference, or else you had understood how pointers and arrays works together. Then address of array of x, that is the start point, that is address of x of 0. What it stores? It stores the starting location, that is 4 variables, 4 into 2, 8. The start address is 448. So address of array x is nothing but address of x of 0, that will be stored in x. So hope you understood this particular problem. Practice, you have to do how you have to access the arguments using the functions and how you have to use the pointers along with the arrays. You please practice. Many programs are being given in your course material as well as in the reference materials. Please practice more programs so that you will have a good hold on pointers concept. These particular topic, pointers, structures, arrays, as I told you before, are very important topics in C programming. So then let us see the pointer arithmetic. So here 1, 2, 3, 4, 5, the 5 values are being assigned to an array x of 5 of integer data type. Then PTR is a pointer variable which is pointing to integer, and here just for example I am assigning address of index 2 x of 2 to PTR. So whenever you access PTR, so 3 will be displayed. Why? Star PTR is nothing but you are using the indirection operator, and whatever the value that is there in x of 3, x of 2 will be displayed. Suppose it is been incremented by 1. So where should it go? To the next location. That is, suppose if you want to display the value of x of 3 using the pointer variable, then you have to write star PTR plus 1. So here you can see we are using a kind of arithmetic in the pointers concept. So suppose if you want to delete 1, like go to the prior position, once again to the prior position, that is assigned to x of 2, and you want to go to the prior position. So there also, as it is in the third position, it will go and print P2. So it started with x of 2, it moved to 1 position, and once again if PTR minus 1 is nothing but it prints the value of 2. So likewise you can increment or else you can decrement. You can increment with 2, 3, whatever the case may be, or else you can decrement. Accordingly the pointer will move in that particular array and gives you the value. Then comes the pointers and structures. So while discussing the structures concept, I told you you can access the members of the structures also using the pointers. Here there is a simple, or else you can directly the structure variables also can be accessed using the pointers. Here it is a simple example. The syntax has been given as struct name member 1, that is member 2 of name structure, then int main. Here Harry is a structure variable, and then star PTR is a structure variable which points to a structure. So here you can notice star PTR is not a pointer variable which is pointing to a variable or else a simple array. Here star PTR is pointing to a user defined data type, that is a structure. So then such kind of declarations also can be done and can be used in C programming. Next thing is accessing members of a structure. So accessing a member of a structure, in our previous case what we had done, we will write the structure variable name dot operator and then the member whatever that we want to access depending upon the structure that we want to refer to. So here with the example you can see struct person, that is the name given to the structure, and it is having 2 members, age and then weight, then main program, then structure person star person PTR and then person 1. So person 1 is a structure variable, but star person PTR is a pointer variable which wants to point to that particular person. So how to access the members using the pointer variable? You can have a similar kind of thing, printf enter age, and we want to take it from the user, scanf %d. This is how we have to access. Ampersand person pointer then age. Here you can see the operator that we are using. Here we are not using the dot operator, however we are using a arrow operator. So in this way, whenever if at all we want to use in the normal way, how you will be using person dot age, person dot weight. That is how in the normal fashion you will be using. Suppose if you want to introduce the pointers in the structures, so this is how you have to use. The second line also, weight also, we are using ampersand person pointer and then an arrow mark and then weight. In this way we have to use the members access whenever we want to use it through the pointers concept. So then comes the C, dynamic memory allocation. So an array is a collection of a fixed number of values, as you know. Once the size is declared, you cannot change. That is a static kind of declaration that we were looking into earlier. Sometimes the size of the array you declared may be insufficient, or else maybe even that goes very small. So to solve this issue, you can allocate member manually during the runtime. There are several functions, among which 4 functions are very much important, and they are: one is memory allocation, malloc, malloc function, calloc function, reallocation function, and then freeing the dynamic memory allocation. We have to use the free also. So one by one we will see, but whenever you want to use these dynamic memory allocation functions, one thing you have to remember, the header file which you have to include is stdlib.h. So this stdlib.h header file needs to be included at the header file declaration. So then only you can use these 4 functions. So malloc is nothing but it is a kind of dynamic memory allocation, and this particular function reserves a block of memory, and then the syntax is ptr is equal to cast type. Like here it may be an integer, float, character, double, whatever the case may be, the data type that you have to mention over here, followed by a star symbol, and malloc function with the size. So here suppose if you want to reserve 100 float values, then you have to write 100 size of float. So this should be remembered, the syntax should be remembered. ptr equal to the data type that you have to remember, what kind of value you want to allocate, for which values you want to allocate, either it may be integer, float, double, or character, then the number of thing into the size. So the above statement allocates 400 bytes because each and every float value have 4 bytes. So 100 is the size, 100 into 400 bytes is the memory allocation dynamically allocated. And then the next one is calloc, that is contiguous allocation. The memory allocation function allocates memory and leaves the memory uninitialized. That there lies the difference. But this calloc function allocates the memory, initializes all bits to 0. So allocation plus initialization is calloc function. You can see here ptr is equal to the same syntax, calloc n comma size. So 25 comma size of the float. This is how we have to use the calloc function. Then comes, these are the differences. It assigns single block of demanded memory and it assigns multiple blocks of the repeated memory. Likewise, you can see the syntax difference, the initialization, wherein which the malloc function allocates the memory, but in the calloc function it allocates the memory and also initialize all the bits to 0. So there lies the difference. Malloc is fast, comparatively this calloc function is slow. So depending upon the context, you have to use either malloc or else the calloc function. Then whenever dynamically the memory is being allocated, obviously you have to use a function called as free. So you must explicitly use this free function whenever there is a kind of dynamic memory allocation in the programs. At the last or towards the end of the program, you write free within the brackets whatever the pointer variable that are being used during the memory allocation, that you have to use here. So syntax is free, within that you have to use the pointer variable, ptr, whatever the case may be. Then reallocation, if the dynamically allocated memory is insufficient, the case may arise, it may be insufficient or more than required. So a kind of statement needs to be used, the function needs to be used, that is the reallocation. The syntax goes in this way: ptr is equal to realloc within the brackets the pointer variable comma x. So here point ptr is reallocated with a new size. The x is nothing but it is reallocated with the new size x.